Before you were born, before your parents ever knew what color your eyes would be, a specific arrangement of genes on chromosome 15 had already decided the outcome, months before your first breath. Your eye color isn't decoration. It's a visible readout of exactly how much melanin your body deposits in a paper-thin layer of tissue called the iris. And that single detail changes, in measurable ways, how your eyes age, how much light damages them over your lifetime, and your risk for specific diseases almost nobody associates with something as simple as color. Brown. This is the baseline, the ancestral default, found in somewhere between 70 and 80% of people worldwide, the highest concentration of melanin any human iris naturally produces. That density of pigment isn't cosmetic. Melanin functions as a biological UV filter, absorbing ultraviolet radiation before it can damage the delicate structures behind the iris. Because of that, people with brown eyes carry a meaningfully lower lifetime risk of two specific conditions: uveal melanoma, a rare cancer of the eye's middle layer, and age-related macular degeneration, the leading cause of irreversible vision loss in people over 50 in the developed world. Brown-eyed individuals also tend to tolerate bright glare and intense sunlight with less discomfort because there's simply more pigment standing between incoming light and the sensitive tissue underneath. This is the iris built for maximum light exposure, evolved and retained most heavily in regions closer to the equator, where UV intensity has been a constant selective pressure for the entire span of human history. Amber. Rarer. Found in a small percentage of the global population, amber eyes carry a distinctive, solid golden brown tone caused by a pigment called lipochrome, combined with relatively low melanin density. Amber sits in an interesting middle zone, more UV protection than the lightest eye colors, but less than true brown, giving it an intermediate risk profile for light-related eye conditions. Genetically, it reflects a specific combination of reduced OCA2 gene activity that doesn't fully shut off melanin production the way it does in blue eyes, just dials it down and shifts its distribution. Hazel. This is where eye color genetics gets visibly complicated because hazel eyes aren't one uniform pigment level at all. They contain a mix of brown and green pigment concentrated unevenly across the iris, often shifting in apparent color depending on lighting and what a person is wearing. That inconsistency itself is a clue. Hazel results from a specific pattern of moderate, unevenly distributed melanin, a genetic middle ground between the high pigment brown pathway and the low pigment blue pathway. Health-wise, hazel-eyed individuals sit in a similarly intermediate risk category, generally faring better than blue or green eyes, but not matching the UV protection of solid brown. Green. Now we're into genuine rarity, found in roughly 2% of people worldwide, making it one of the least common naturally occurring eye colors on Earth. Green results from a low overall melanin level combined with a phenomenon called Rayleigh scattering, the same physics that makes the sky appear blue, scattering shorter wavelengths of light off the collagen fibers in the iris stroma. Because green eyes carry significantly less melanin than brown or hazel, the health picture shifts accordingly. Measurably higher sensitivity to bright light, and research consistently places green-eyed individuals, alongside blue and gray, in the higher risk category for both uveal melanoma and age-related macular degeneration, specifically because there's less pigment-absorbing UV radiation before it reaches the deeper eye structures. Gray. Even rarer than green in most populations, gray eyes result from an extremely low melanin concentration, combined with a slightly different collagen fiber density in the iris than blue eyes, which scatters light in a way that reads as a cooler, more neutral tone rather than blue. Functionally, gray eyes share nearly identical health considerations with blue eyes, elevated light sensitivity, and the same UV-related elevated risk profile that comes with minimal iris pigmentation. Blue. Found in roughly 8 to 10% of the world's population, concentrated most heavily in Northern and Eastern Europe, blue eyes carry the least melanin of any common eye color. And here's where the genetics get genuinely remarkable. But heterochromia can also be acquired later in life, And this is the part that matters medically. Sudden onset heterochromia in an adult, an eye that changes color when it never has before, can be a warning sign of underlying conditions ranging from eye injury and inflammation to, in rare cases, ocular tumors, which is why ophthalmologists treat newly acquired heterochromia as something worth investigating rather than dismissing as a curiosity. And then there's the true statistical edge of human eye color variation. Red and violet eyes, so rare that most people will never encounter one in person. These extreme cases occur almost exclusively in individuals with ocular albinism or oculocutaneous albinism, conditions where the iris produces essentially no melanin at all. With no pigment to reflect or scatter light, the iris becomes translucent enough that the red blood vessels lining the back of the eye become visible through it, sometimes appearing genuinely red or, under specific lighting, a violet tone. This isn't a beautiful genetic rarity in the way it's often romanticized online. It comes paired with significant vision impairment, extreme light sensitivity, and, because melanin's UV protective function is essentially absent, the highest documented lifetime risk of UV-related eye damage of any pigmentation category that exists in humans. Your eyes are running a UV filtration system built entirely out of pigment density, and the amount you happen to inherit, somewhere on a spectrum running from the maximum protection of solid brown down to the near total absence of it in albinism, quietly shapes your risk profile for specific diseases every single time you step outside without sunglasses. None of it is a character trait, and none of it was a choice. It was decided by a handful of genes on chromosome 15 before you had a face at all, and it's been quietly filtering the world you see and protecting or exposing the tissue doing the seeing every day since.